Here we go. So we're going to repeat a collection of decisions that our little robot makes. And how many times are we going to repeat it? We're going to repeat it however many times we set it in our steps variable. Remembering that the more steps you include, the more floor tiles you'll end up with. And why is that? Well, I'll show you right now. First thing we're going to do in each step is we're going to talk to our grid using a special form of syntax that works with data structures. So I'll type this in and then I'll explain it a little bit. We're going to have this sharp sign, and then we're going to say controller underscore X, controller underscore Y equals floor. And what we're doing there is we are setting the current slot as a floor tile. Okay. So let me explain this a little bit. With the data structures in GameMaker, and in particular a grid data structure, remember it's just a 2D array. And with data structures, if you want to set some value into that data structure, you have to use a special character, this sharp sign, and which is called an accessor. And basically what this is doing is it's telling the data structure, hey, data structure, what I want to do is to store a value in the data structure at the location I'm about to tell you. So that this is just it's really a kind of safety measure with data structures, that you can't you can't accidentally go into a data structure like this and store some value in it. So here's an example of our data structure. This is where we set up some region of the data structure with values. If you go into the help, you'll see there's a whole section here on DS grids and how they work, and all of the different functions that work with them. And in that section, it will tell you that if you want to add or modify the contents, you need to use a special expression called an accessor, which is this little sharp sign. Okay? All right, so that's what we're doing. So what is happening is wherever our little robot is currently, that's what's stored in the controller X, controller Y, and when we first start, remember it's sitting right on the middle of our checkerboard, we're going to store a value in that cell of our checkerboard, and the value we're going to store in it is whatever we set as our floor when we created our macros. And again, the number doesn't matter, but it's a -5 if you're curious. Okay, so initially we set every cell in our checkerboard to be void, and now in this big old repeat loop, we're going to set the first cell that we stand in, which is right in the middle, to be a -5 or floor. Okay. Then we want to have our little robot, that little controller, move around. And we want it to move around in some random direction. So we're going to say if irandom direction change odds equals direction change odds. Type this and then I'll explain it. Controller underscore direction equals irandom 3. Huh? So what does that mean? Well, we set our direction change odds value to be 1, right here. Okay? And I said that if you make this, I think what I said is if you make it 0, it will never change, and if you make it 1, it will always change. That's not quite accurate, to be honest. The way it actually works is if I made this number bigger, just like we did in earlier assignments, where it's like we're creating a multi-side die. And the larger the number is, the more sides there are to the die, and the less likely it is something is going to occur, because you basically are rolling the dice. And when you roll the dice, if it comes up with a specific value, then you do whatever it is you want to do. So what I should have said is that by setting the number to 1, we're creating this imaginary one-sided dice, meaning that it's always going to happen. Whatever we want to happen is always going to happen, right? So I say, if irandom direction change odds equals direction change odds, then do this thing. And let me clarify even more. With this irandom direction change odds, this could potentially be 0 or 1. So I guess we're doing a 50-50 chance rather than a 100% chance. So it's either going to be 0 or 1. And so half the time, roughly, we will change directions. And which direction will we change into? Well, right, up, left, or down, using this irandom 3. Okay, so sorry for the confusion on that. Okay, so that's where we may or may not change directions for our little robot. Let's comment this so we know what the heck we're doing. Possibly change directions. And when you're creating this yourself, you can try setting this to something different for the odds, making the number bigger, just to see the visual impact it has. Or you could randomize the direction change odds. So sometimes when you generate a room and there's a high likelihood of the controller changing directions, and other times there's a lower likelihood of it. Play with these things and see how they work for you. All right, so here we're possibly changing directions. Rolling the dice to see whether or not we're going to try a new direction. Okay, then let's move our controller. Move the controller. I still think of it as a robot. Move the robot through the grid. Move it one position, right? Because this is a set of steps. All right, so we're going to move off in some direction, one cell, one slot inside our checkerboard. All right, so let's create a new local variable called x underscore direction. Set that equal to, let me type this in and then I'll briefly explain it, length dir x 1 controller direction times 90. And let me keep typing and I'll explain after I type a couple of lines in here. We'll have another local variable y direction, length dir y, and the same thing, controller direction times 90. So what are we doing here? We're creating a local variable to tell which direction we want our little robot to move in this step from wherever it is inside our checkerboard to one of the adjoining slots inside the checkerboard. And this length dir x and length dir y, we've used this before. Imagine that you are creating a vector inside GameMaker, all right? And so here we got like a triangle is another way to think about it. So imagine here is our little robot, and we need it to move off either here, 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 or here. And so what we're getting is the length between this location and this location that we would need to move in order to reach this spot, or the length of the y that we would need to move in order to reach this spot. Okay? That's what's happening here. So in order to get that, in order to know which direction we're moving, in order to find out the length of the x and the y that we need to move, we are just passing a 1 for the x position, or the length, I guess I should say, and then we're taking whichever the direction is, it's going to be 0, 1, 2, or 3 times 90, and the same thing for the y. Okay? And that will give us the x direction and the y direction that we want our little robot to move. Then let's update the controller x by adding to it this x direction. Okay, so we're updating our controller x and our controller y. Remember, we're using what we're storing in this controller x and controller y are the position inside our checkerboard. Okay. Copy and paste that. And update that to add to it the y direction. This is a slot in our code that even as I'm describing it, I understand is confusing. So this is one of those places where I encourage you, after this video, to sort of go back and walk carefully through and make sure you understand. But the basic idea here is we need to update the position of our controller so that it is going to move one slot right, up, left, or down in the checkerboard, in this grid. And in order to figure out which direction we want to move as we move one slot right, up, left, or down, that's what we're doing right here. Okay? Okay. And so that within a given step is going to give us a new position inside the array, and then when we run the next repeat, we will go to that slot in the grid and we will set that slot equal to floor. So the effect is our controller starts in the middle, sets that slot to a floor, then it moves one slot left, right, up, or down, sets that into a floor, then it rolls the dice to see which direction it's going to go next, moves that slot one slot over, sets that, so it just keeps doing this, right? Now, if you understand that concept, then you'll understand why the larger the number of steps, the more likely it is you're going to have lots of floor pieces, or the more floor pieces you're going to have. Because as your robot is cruising along through this checkerboard, setting each slot it lands onto a floor, obviously the more spaces it moves to, the more floor you're going to have in the room, and the fewer steps, the fewer floor spaces you're going to have. That's how that works. All right. We're going to do a little bit of cleanup now. So this is just the regular marching of our guy through the room. One more thing I want to do in here is that I'm going to make our little robot never come closer to the edge, top, bottom, left, and right of our checkerboard than 2 slots. Okay? And what the effect of that will be is that we won't be able to have a floor existing right out to the edge of our grid, which kind of makes sense. We want to make sure that the outer edges of our grid aren't floors. Okay? So we're going to say if controller X is less than 2, or controller X is greater or equal to width minus 2, then do something. And what do we want to do? We're going to say controller x plus equals x direction times 2. All right, so what is this? What does that mean? Well, each step our little robot is moving through the grid. And so potentially, and highly likely as a matter of fact, there'll be a time as it's walking through these many steps that it walks close to one of the left edge or to the right edge of the checkerboard. And if it does that, then we're going to update its x position so that it can't do that. So initially it'll move within a pixel, or I should say within a cell or two of the left or right of the checkerboard. And when that happens, we're going to say, no, you can't go into that position. And we're basically going to pull it back from the edge of the checkerboard. And that's what we're doing right here. Okay. So that takes care of, so we'll say don't let the controller go to the edge of the grid. That takes care of the left and the right side. We need to do something similar to the top and the bottom. So I'm copying and pasting and replacing x's with y's and replacing width with height, and then pulling it back from the bottom or the top. Okay. Wow. All right, let's save what we've got up to this point. Everything we've done here is just setting up spots in our grid, spots in our checkerboard, spots in our level, spots in our room that we want to be floor. And so right now, behind the scenes in our invisible checkerboard in this data grid, every slot is filled with either void or floor. But up to this point, nothing is showing up in our room, right? All we've done is set up things behind the scenes. We're going to end this lesson here, and in the next section of the lesson, we'll connect these slots in this behind-the-scenes grid to actual tiles that we want to show out in the room. All right, welcome back. We're continuing on our short series of lessons on creating an auto-generated level for an RPG game. In the last lesson, we created a data structure, a grid, and we initialized each slot in the grid to be void, and then we created a little controller, a kind of behind-the-scenes robot that walked through the grid at random, placing floor tiles wherever it landed. Up to this point, everything we've done is purely sort of behind the scenes. We haven't connected any of our work to this point to actually anything visual in the room. So that's what we're going to do now. So come under where you left off last time, and we will say now show some tiles. All right, and how are we going to show some tiles? Well, this is a little complicated, so stick with me. I'll do a lot of typing and then I'll explain as I'm going along. Now we have created our grid and we've set each of the slots in the grid to be void or floor. Now to show actual tiles out in the room, we are going to march just one time through the grid, going column by column, row by row, checking what the value is in our grid for each slot, and then using that information coupled with a very somewhat complicated bit of math called bit masking that's making use of binary numbers in order to select a specific image that is part of a tile set or a tile map um, and place it out in the room at the appropriate location. So for this to work, we come out of our create event, you need to import the image of the tiles that is up on the Blackboard site. I've placed it up there for you already. I don't think I've put it in here yet, so that's fine. We'll do it now. So create a new sprite and go to import, and you'll want to find where on your computer you download the image that I put up on the Blackboard for you, and then bring it in. It's called S-Wall Tiles, so just grab it, bring it in, give it a name. I'll call it in here also I'll call it S, oh, you can pick name it whatever you want, I guess it doesn't matter. Call it S-Tile Walls. Close that up, and then I'll create a tile set out of that sprite. So resources, create tile set. Choose the sprite that you just brought in, and then in the tile set properties, you want to set the tile width 32 and the tile height to 32 as well. Let's take a look at this for just a minute. I'm not in this video going to go into very many details about how we're going to use bit masking in order to select the correct version of an image in this tile set to display out in the room. But just briefly, I want to point out, if you count how many images there are, we've got 1, 2, 3, 4, and then we've got, what, another 10, that's 14, 15, 16. And what we're going to do when we get to the part of this where we're selecting which image to show is basically coming up with a number that is somewhere within the range of 16. And if you look at what's happening in this set of images, is that they are each different, and so using a way more complicated hunk of math than it's worth explaining, we will correctly choose which one of these we want to use. And these have been set up and arranged in a very specific order in order to make that work. Okay. Let's go back into our level object and go back into the create event and get back to the part where we can go in and actually start producing some stuff that will show up inside the room. Okay, so as I said, we're going to march through our grid one time, and we're going to use some nested for loops to do that. So we're going to say for, and I'm going to create a local variable called y that we're going to use to figure out which position in a given column inside that grid that we've created we are currently looking at. So we're going to say var y equals 1. Notice the underscore I'm putting at the beginning of the y. That's just following the naming scheme that Benjamin Anderson used, who is the creator of the original version of this script. So in case you want to go in and do a lot more than what we're doing, you can look back to his YouTube videos that I've linked on our website, and they will allow you to go really deep into this. So what we're doing basically is we're saying we're going to start at 1, and we're going to start counting through, or we're going to repeat as many times as the height of our grid minus 1. And that's because we don't want to go all the way to the end of this thing, because the height includes value that would take us actually 1 slot beyond the end of our grid. Okay. All right, then we're going to do a nested loop. So that's going to go row by row, or I should say line by line, column by column, but we also want to go row by row. So we're going to say var x equals 1. X is less than the width, if I can spell correctly. There we go. Minus 1, and then our own version of x plus plus. Okay. Okay, so we start at basically the upper left-hand corner of this grid, and then we're going to march our way through every single cell in it. And what are we going to do while we're in there? Well, we want to check using yet another if. We're going to look into our grid, and to read from or write to a data structure, this data structure grid that we're creating, it has a kind of special syntax that you need to use. And the syntax is this slash or hash character. That's called an accessor. And basically what that does when we list the name of the grid that we're going to be looking at, and we include this hash character, that accessor says, hey, I want to be able to read the grid. It's basically a kind of safety feature, right? So where do we want to look in the grid? We want to look at wherever we are currently. So we'll start at 0, 0, and then we'll work our way through. And what is it we're checking for? I want to know if the space where we're standing is not equal to floor, okay? And if it's not equal to floor, then what we want to do is choose one of the images in our tile set to place in the location that's not a floor. If it's a floor, we just won't put anything there. We already have a background image out in the room, and that will just show through. But if it's a void, we're going to choose one of the wall sprites from the tile set to show out in the room. Now here's where we get really tricky, and we start to use this crazy sort of math that I'm not going to explain too much, but let me show you what we're going to do. Let me type it in, and then I'll explain it. I'm briefly getting lazy here. All right, what we're going to do is we're going to create 4 local variables. I'm going to call one north tile, west tile, east tile, and south tile. Now if I go all the way back to where we started all of this, we created some macros at the very beginning of this project. Remember, we made a script, and we had macros called north, west, east, and south. And I told you that those numbers are very important. You need to have 1 with north, 2 with west, 4 with east, and 8 with south. You may notice 1, 2, 4, 8. Well, this is going to be connecting into the idea of binary numbers. Anyway, so here we're going to have similarly named variables. Okay, we've got a north tile, west tile, east tile, and south tile. And what are we going to store inside each of these local variables? Well, let's pay attention here just to this north tile for a minute. We're going to look into the grid, and we're going to check where we are right now on the X position in the grid, and we're going to check where we are -1 on the Y position in the grid. So what that means is that we're going to go 1 cell above where we are currently in the grid, and we're going to check if that 1 cell above us is void. Okay? If 1 cell above us is void, then we're going to return true, right? If 1 cell above us is equal to void, that will return true, which is also saying return 1. So we'll store 1 in north tile. If it's not true, if the thing above us is not a void, meaning it's a floor, this will return false, and then we'll have a 0 in the north tile variable. So each of these can be either 0 or 1, depending on whether the space in the grid that we're checking, here we're looking above us, here we're looking to the left of us, to the right of us, and below us. And if any of those slots is void, each of these would be 1. If any one of them could be 1, and if any one of these is equal to, is not void, then that one would be 0. So 0 or 1. Okay. What are we going to do with that information? Well, we're going to do bit masking, which is too complicated to explain. Just use this. I know it's not always satisfying. You want to know what's going on. In the link on Blackboard to the original set of videos from which I'm deriving this lesson, even old heart beast Benjamin Anderson found it too complicated to explain, so he put in a link to yet another person trying to explain it. So if you really want to get into it, you can look back at his original videos, which don't explain it, but do include a link to somebody else trying to explain it. All right, we're going to create a local variable, and we're going to call it tile index. And what this variable is going to store is the number of the position in our tile set that we want to use and show out in the room. Okay? So it's just going to store a number that we can use that will represent which of those images do we want. And how are we going to get those? This is where things get a little weird. Saving a little time again, I'm just going to paste this in. So we're going to get this value by taking by taking our north value, which if you remember was 1, multiplying it by what is stored here, so that's going to be 0 or 1. So it's going to be 1 or 0. And then we're going to add to that our west value, which was 2, times 0 or 1, our east value, which was 4, times 0 or 1, and our south value, which was 8, times 0 or 1. And then we're going to add to all of that 1. Okay? Again, I'm not going to explain it, but what this will do when you add all of this up, it will, believe it or not, give you the correct number for the sprite that should be shown in the position that we're checking currently inside the room. Okay? So, how do we actually then position that thing out in the room? We can use a built-in function called tilemapSet. TilemapSet needs to know which tile map are we talking about. And for that to work, we have to do one more thing. So I'm going to save this, and I'm going to come back to our workspace for a moment, and I'm going to go over to our room, open it up, and out here in our room, we have, remember, this layer called wall tiles. It's got nothing in it right now. We need to associate that layer with the tile set that we just created. And I'm a little lazy, so I didn't name it. I probably should have. In fact, to be neat, let's name this thing. Oh, what am I going to call it? I'm going to call it, let's call it T walls for my tile set. Let's double check our room to make sure I just didn't wipe out this. Okay, no, it's still pointing to T walls. Okay. Let's go back into our script, and this tilemapSet function needs to know which tile set is it going to be working with. This tilemapSet function is going to allow us to place a specific image from a specific tile set out into the room. So tilemapSet, we tell it, all right, we want to know, let's see, wall map ID. Remember when we set this, we set this up earlier. Wall map ID is pointing to the layer that includes the tile set that we want to work with. Okay, so I guess I should say this is pointing to a layer in the room, but it's pointing to the layer that contains the tile set that we want to modify, okay? Or that we want to use to place tiles. Then I need to let this function know what's the number of the image in the tile set that I want to place out in the room. So whatever we just stored in tile index. Then we need to say, where do we want to position that image, that tile? And we want to position it where we're sitting right now inside our grid. Right? We're at X and Y. Okay. All right. That will do it. That will place that out into the room. Now there's a whole bunch more we need to do with this, but let's come through and close out each of these for loops and close out this big old if statement as well. Right. And before we go on, let's give this a try. I want to do one more thing here before we give it a try, which is, I'm going to close this out. I want to be able to regenerate custom levels by pressing just a regular old key on my keyboard. So to set that up, I'm going to go back into my player. And in the player, we worked with this back in our RPG game. It's in the player that we are detecting input from the user. So I'm going to come to the beginning of my move state on the player, and I'm going to copy this attack input, and I'm going to copy this attack input that we created before, paste it in, and I'm going to rename it, and I'm going to call it reset input. And instead of checking for the X key, I'm going to check for the R key. So this will allow us to check if the player is pressing the R key on their keyboard. Then I'm going to copy this if attack input is true, paste underneath that, change it from attack input to reset input. And then what do I want to do if they press the R key? I want to restart the room, which is a built-in function called room. Restart. Okay. So again, we're detecting if they press the R key. If they do, we'll restart the room. One more thing. We're getting closer to be able to see what this looks like. I'm going to come back now to my O-level object. And in the O-level object, all we have right now is the create event. And in the create event, we're creating a grid, a data structure grid. I want to be very cautious, though, because I've set up the ability to detect when the player hits a key that will be used to reset the room. And when the room is reset, it's going to run this create event again, and the create event is going to create a data structure grid. Right now what will happen is each time the player hits the R key to restart the room, we will create another grid data structure. And each time we create a grid data structure, we are increasing the amount of memory that our game is setting aside and that span. So what we want to do is clean things up so that if we restart the room, we're going to destroy the data structure that has been created. So I'm going to add an event called cleanup, which does just what it sounds like. And in cleanup, we're going to call a built-in function called ds grid destroy, and then I need to say which grid do I want to destroy? Well, the one that we create in the create event. So this functions very much like instance destroy, where you're basically wiping out a game object and releasing its memory so that you're not using up memory unnecessarily. Same thing here. We are destroying the grid that was created in the create event so that we free up the memory. All right. We're almost ready to give this a try. Let's go back into our room. I'm going to select the player layer. And in the player layer, currently we've got the player, we've got the camera, and we have a controller object left over from our RPG game. Here in this same layer, I'm going to place an instance of that O-level object that we've been working on. Hit run, and we'll see if we've made any mistakes. Ooh, it's very exciting. So here we've got our guy. He's not placed properly, but you can see we've got walls and we've got floor. If I hit the R key, we get a new room, 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 and so on. One thing to notice while we're here is that because of the number of steps that we're using to move our little robot through the grid, placing data to say that we want to have floor tiles there. We're not doing very many steps, so we don't have a lot of floor tiles. So I mentioned when we were setting this up that the more steps you include, the more floor you'll have, right? Because the more that little robot, that little controller, will place floor tiles. So let's set it to 800. Now when I start the room, we should see less wall and more floor. See, here we go, more floor. Well, not much here. Huh, that's interesting. Well, we don't know exactly because we haven't seen our little guy placed out in the room. So we're going to stop this part of the lesson here. And in the next section, we're going to place our player out into the center of the room. We're going to do a little bit of optimizing of our room. And we are going to then place enemies and plants out into the room as well.